All right, so before we get into this chapter, we're just going to touch up on some of our properties of exponents. All right, properties of exponents. So remember, anything raised to the 0 power is going to be equal to 1, all right, as long as if a does not equal to 0. So it could be anything that we have, and it could be written like that, or it could be written in parentheses. That means this entire parentheses will be equal to 1. All right, so anything raised to 0 is 1. When we are dividing and we have the same base, so it's important that this base is the same, meaning a and a, that's our two bases, so it's important that our base is the same. And if they're the same, then we just subtract our two powers. So when we're dividing, we're subtracting, all right? And it just makes sense. If we have x cubed divided by x squared, well, if we expand out our numerator and our denominator, it means x times x over x times x. And here we can cancel out two of these x's, and then we're just left with x or x to the first. All right, and we can get that by just saying x to the 3 minus 2. All right, here, if we have anything raised to a negative power, what a lot of people want to do is they just want to raise, say if we have 2 to the negative second power, a lot of people will just want to say, okay, well, that's equal to negative 4, and that is wrong. Right, that is incorrect. So what we need to do is when we have a negative power, we need to pretty much take its reciprocal. We need to flip where it's at. So this 2 to the negative 2 power, since 2 was originally written in our numerator, we would rewrite this as 1 over 2 squared. So it needs to drop or go to our denominator. So we take its reciprocal. And then this is equal to 1 over 4. All right, so then that would be your final answer for that problem. And what a lot of people want to do as well is if they see negative 2 squared, they will want to rewrite this as 1 over 2 squared and say that this is equal to 1 over 4. And this is wrong as well. So just make sure you're paying attention to where it's at. So the negative needs to be in your power. All right, if we have two bases, so we have two bases that are exactly the same. Here we have a, and we're multiplying, then we would add our powers together. All right, so it would be a to the n plus n. If we have two numbers in a parentheses, as we do here, and it's being raised to a power, we can distribute that power into both, so it's a to the n times b to the n. So each individual number can just be raised to that power. Now the rule here that a lot of people mix up is when we have a power to a power, we need to multiply them. All right, so let's just go back to this one here again and show why you add. So if we have x squared times x to the third, if we expand this out, we have x times x for this x squared, and then it's times, we have to expand that x out 3 times, and now we have 1, 2, 3, 4, 5 of them, so it's x to the fifth, or we could just have added 2 and 3. Here, when we have a power to a power like we do here, we need to multiply them. So let's say we have x squared raised to the third power. All right, so a lot of people just want to add these together and say it's x to the fifth. But if we expand this out, this means that we have x squared times itself 3 times. All right, so we're multiplying it by itself 3 times. So we can use this power now, since we're multiplying them all, that we can add them. Or let's just expand it out and show how it works. So this x squared is broken down to 2 x's. This x squared is broken down to 2 x's. And this x squared is also broken down to 2 x's. So we have now 1, 2, 3, 4, 5, 6 of them. So it's x to the 6th power. All right, so power to a power, you multiply. And the same thing as we did for this one, how we could distribute the n in when they were being multiplied to each other. If we have two numbers that are being divided and it's being raised to a power, we can still distribute that power into both our numerator and our denominator. And we can look at them separately. All right, so those are just a quick review of all the properties that we have. Let me erase all the writing that we have on here. So if you need to, you can pause this and take a screenshot and study these powers. All right, so it's something you definitely would have learned in Algebra 1. All right, now we're just going to do a few examples, and then that's it. All right, so the first example is if we're multiplying this together, we would multiply our likes with our likes, meaning we would multiply our two constants. So 2 times 5, that will give me 10. All right, so we know that this is going to be equal to 10. And then here we have a cubed times a to the fourth. So since they both have the same base, we can add our powers together. So it's a to the 3 plus 4, or our final answer is 10a to the 7th power. All right, so when we have the same base, we can add our powers. And when there's numbers out front, we can multiply them together. All right, that's it for the first example. You can replay this again or try it on your own. I'm just trying to keep this video a little quick. All right, so this second example now has a few things that we need to do. So now we have 3 different things that are being raised to the second power. So we will distribute this second power to all of these. And now we need to think here. So we can rewrite this as 3 squared. And then x. Now we got to remember, power to a power, we need to multiply. So 2 times 2 gives me 4. And then here we have power to a power again, and it's 3 times 2. Here, let me erase this just to show step by step. So here it'll be x to the 2 times 2 power. Here for y, it'll be y to the 3 times 2 power. Since it's power to a power, we have to multiply. All right, and then they give our final answer. 3 squared is 9. 2 times 2 is 4, so it's x to the 4th. And 3 times 2 is 6, so it's y to the 6th. All right, so when you distribute that power into each variable or constant, and then from there you just need to make sure power to a power you multiply. All right, just 2 more examples, and that's it for this video. All right, so this one's actually quite easy. It might look like it's a little bit hard, but remember, for this 0, we would distribute it into each thing. Or we know that this entire parentheses is being raised to 0 power. And anything being raised to 0 power is equal to 1. So this final answer is simply 1 over 3xy squared. And that is it. Right? Nothing else you can do. You could distribute the 0 in and look at 6 to the 0 and then x to the 3 times 0 and say, all right, well, 6 to the 0 is 1. X to the 3 times 0 is x to 0, which and that means x to 0 is also equal to 1. You could do that if you wanted to, but there's no need. Once you see the entire thing is being raised to 0 power, that entire parentheses is then just simply equal to 1. All right, and then last example, and then that's it for this video. All right, so for this last video, I'm going to do this 2 different ways. So the first way is we're going to distribute this -1 into every single variable. So each one of these variables is going to get multiplied by this -1 in both our numerator and our denominator. All right, so let's go through, and just to keep this a little bit quick, I'm not going to write it step by step. We're just going to multiply right away. So r to the -1, well, -1 times -1 gives me +1. S squared will give me s to the -2. T to the -3 times -1 is t to the +3. R to the -2 times -1 will give me r squared. S to the 0 times so it's still going to be s to the 0, which we know anything raised to 0 is 1, so we don't have to write that. And then our last one, t to the 1st times t to the -1 is t to the -1. All right, so now we have this fraction after we distribute the -1 in. And now we can just do our rules. Here we know that we have two r's in our denominator and 1 r in our numerator. So I know I'm going to be left with an r down here. Or you can say r to the 1 minus 2, which is then equal r to the -1, which is then equal to 1 over r. All right, so we can get it that way. Here we have an s to the -2 in our numerator. So in order to make this positive, we need to then change its location. We need to take its reciprocal. So this s to the -2 is then going to drop to our denominator. So it becomes rs squared. And the same thing here, we have t to the -1. So we can move this up to our numerator, or we could say, since we're dividing and we have the same base, we can say 3 minus -1, which we know turns to plus, so it's t to the 4th power. Oops, sorry. And that will then be t to the 4th power. So whenever you do your division, whether if it's negative or positive, it always remains in our numerator. All right. So even if it's negative, it goes into our numerator first, and then we can drop it down. And even if it's positive, it stays in our numerator. So we could have also brought this up and got t cubed times t to the 1st, which we then know is also t to the 4th because we're adding them together. All right, so anytime you're dividing and you're subtracting, no matter, even if it's a negative, it still is going to end up in our numerator, and then we would just have to drop it down after. All right, but that's our final answer for this one. All right, we're just going to do it one more way, and that's it for this video. Right, the other way that you can do this is, since this is being raised to a negative power and it's this entire parentheses, everything in here is being raised to that, to make this positive, we could just go ahead and take the reciprocal of our fraction. So that means to make this a positive 1, I'm taking my denominator and I'm rewriting it as my numerator. Let me just change this color so we can see it a little bit more. But I'm going to take this denominator and I'm going to rewrite it as my numerator, and then I'll take my numerator and I'll rewrite it as my denominator. All right, so it'll become r to the negative 2, s to the 0, t to the first, over top of r to the negative 1, s squared, and t to the negative third. And now, since we flipped it, and we took its reciprocal, this negative 1 then becomes positive 1. And anything raised to 1 is itself, so we no longer even have to worry about that power. All right, so now we can just go ahead and do our rules. When we're dividing, it'll become r to the negative 2 minus 1, so it's r to the negative 1. So we know that that needs to flip 1 over r. So in this fraction, I know r is going to my denominator, so I did those. This will then be s to the 0 minus 2. So it's s to the negative 2. So once again, I would have to flip this and it becomes 1 over s squared. So it'll be s squared. And then here we have t. We have 1 minus negative 3. That turns to plus. So it's t to the 4th power. All right, so no matter how you do it, either way, you can take your reciprocal first to make this power positive, and then just do your rules that we've learned, or you can distribute it like we did before. But either way, we get t to the 4th over rs squared. T to the 4th over rs squared. All right, I know this video is a little bit long, but we had to go through a few different examples just to practice those. All right, and that's it for this video.